Hi, today we're going to evaluate the derivative of each of the following functions. First one is y equals x squared plus 4x minus 3 over x squared plus 4. Second one is y equals x cubed minus 1 over x cubed all to the power 9. By derivative we mean to differentiate. Let's start with the first question, which is f of x equals x squared plus 4x minus 3 over x squared plus 4. Here you can see that's a fraction, so therefore we use the quotient rule. From the log table we see that the quotient rule is dy dx equals v multiplied by du dx minus u multiplied by dv dx all over v squared. In this question, u is x squared plus 4x minus 3 and v is x squared plus 4. Let's deal with v first, which is x squared plus 4. To differentiate a function, we apply the following. Let y equal x to the power of n, and then dy dx will become n multiplied by x to the power of n minus 1. Also, when differentiating a constant, which is a number, let's say c, the result is always 0. Let's apply that to v, which equals x squared plus 4, which when differentiated becomes 2x to the power of 2 minus 1. The constant 4 goes to 0, and 2x to the power of 2 minus 1 just equals to the power of 1, which is just 2x. So dv dx equals 2x. For u, it is equal to x squared plus 4x minus 3. So du dx equals 2x to the power of 2 minus 1 plus 4 by 1 all multiplied by x to the power of 1 minus 1 minus 0. So since x to the power of 1 minus 1 equals x to the power of 0, which is just 1, that just becomes 4. So du dx equals 2x plus 4. So in full we have v equal to x squared plus 4, u equal to x squared plus 4x minus 3, v squared equals x squared plus 4 all to be squared, du dx equals 2x plus 4, and dv dx equals 2x. Subbing these into the quotient rule, we get dy dx equal to x squared plus 4 multiplied by 2x plus 4 minus x squared plus 4x minus 3 all to be multiplied by 2x divided by x squared plus 4 all to the power 2. To solve this, we multiply out the brackets. We multiply each term in one bracket by every term in the other bracket. This gives us x squared to be multiplied by 2x plus 4, plus 4 multiplied by 2x plus 4, minus 2x to be multiplied by x squared plus 4x minus 3, all over x squared plus 4 all to the power 2. Be careful with signs when you're multiplying out, and the answer for this is 2x cubed plus 4x squared plus 8x plus 16 minus 2x cubed minus 8x squared plus 6x all over x squared plus 4 all to the power 2. By identifying like terms, you can see that it's easier to say that dy dx equals 2x cubed minus 2x cubed plus 4x squared minus 8x squared plus 8x plus 6x plus 16 over x squared plus 4 all to be squared. By grouping the terms together, we get the final answer of dy dx equal to minus 4x squared plus 14x plus 16 over x squared plus 4 all to be squared. And apologies, but you can just ignore the minus 2 circled in blue. And then the next question, which was y equals x cubed minus 1 over x cubed all to the power 9. So since there's a power outside the bracket, we use the chain rule. So from the log table we see that the chain rule is if y equals u to the power n, then dy dx equals n by u to the power of n minus 1 multiplied by du dx. Here you get the derivative of the bracket as a whole, then multiply by the derivative of what's inside the bracket. So in the equation y equals x cubed minus 1 over x cubed, all to the power 9, u is simply x cubed minus 1 over x cubed. Remember that a to the power minus 1 equals 1 over a. So similarly, 1 over x cubed equals x to the power minus 3. Therefore, u equals x cubed minus 1 over x cubed, which is equal to x cubed minus x to the power minus 3. So du dx equals 3x to the power of 3 minus 1 minus 3x to the power of minus 3 minus 1. So here, please note that a minus sign multiplied by another minus sign gives a plus sign. So du dx becomes 3x squared plus 3x to the power minus 4. So since 3 is a common factor, we can put it outside the bracket, giving us 3 multiplied by x squared plus x to the power minus 4. So the initial function was y equals x cubed minus 1 over x cubed all to the power 9. So for the chain rule, we have to bring down the power outside the bracket, which is 9, to outside the bracket. And then also you take 1 away from the power, which leaves us with dy dx equal to 9 multiplied by x cubed minus 1 over x cubed all to the power of 9 minus 1 multiplied by du dx. We worked out du dx to be 3 multiplied by x squared plus x to the power minus 4. Therefore, dy dx equals 9 to be multiplied by x cubed minus 1 over x cubed all to the power of 8 multiplied by 3, which is multiplied by x cubed plus x to the power minus 4. This can be written as 9 multiplied by 3, which is then multiplied by x cubed minus 1 over x cubed to the power of 8, which is then multiplied by x cubed plus 1 over x to the power of 4. So the equation y equals x cubed minus 1 over x cubed all to the power 9 becomes dy dx equals 27 multiplied by x cubed minus 1 over x cubed all to the power of 8 multiplied by x cubed plus 1 over x to the power of 4. And this is your final answer for this question. So here are some important notes for when you're finding the